Well, we got a pretty interesting morning around the central part of the United States, both in the northern latitudes and in the southern latitudes. The surface map kind of testifies to that. Widespread light snow across the state of Wisconsin, and just maybe a flurry or two here in Madison even this morning, and that might last for some part of the morning, but not the whole day. And then the temperatures will start to moderate a little bit during the day today. We're dominated by high pressure. Unfortunately, there's no isobars on this map this morning from 8:14 local time, but one gets the sense that there's high pressure over the northeastern U.S. and the Great Lakes states, and then a couple of regions of low pressure moving across central Ontario and then across Montana. Even more interestingly, although more remote, is the outbreak of really intense convective activity across Texas, Arkansas, parts of Mississippi and Alabama, as well as most of the state of Missouri. So that's all shown in the green, yellow, orange, and red reflectivities on this instantaneous map. And we'll look at this in a little bit more detail. It's quite an active day across the lower Mississippi River Valley, and the threat for severe weather is quite high in a lot of locations, and I'll show you a map of that too as we go through the discussion. Not too much unsettled weather right along the immediate west coast. We'll see when we go to the satellite over the Pacific, though, that over the Gulf of Alaska, making landfall on the peninsula, Alaskan Peninsula, there's a couple of storms really nicely developed and nicely illustrated in the satellite movie, so that'll be something to look for when we go there. So pretty active day in the south central United States today, and one that will probably make some news as the day moves forward. The temperatures in the region where the weather is going to be interesting are very warm. Look at this. This is 7:30 a.m. local time. Temperatures in the low 70s, all the way from Baton Rouge to Pensacola, Florida, and then down to the coast of Texas and the Texas-Mexico border. So very, very warm temperatures down over the extreme southern Gulf of Mexico. And then they're in the 60s everywhere else in the southern states, except for the Carolinas, which are a little bit cooler. But a large pocket of warm air across the southern states where most of the current convective activity is taking place, although not all of it. Some of it's in Missouri, where in the northern part of the state, temperatures are relatively low. We're 32 here in Madison, 27 in Green Bay, 34 in Chicago. So widespread temperatures in the low 30s, as one might expect out over the northern plains states. And those temperatures won't move very much more than into the low 40s today if we're lucky. So this warmth is going to stay sequestered to the south throughout the day, it appears. And so the severe weather will probably stay down there as well. A little bit warmer along the west coast, even though it's quite a bit earlier in the day. It's 5:30 a.m. there, and it's 35 already in Seattle and Portland. It'll probably be about 50 in those places today, and even warmer along the coast of California. And then keeping these temperatures in mind along the Texas, Louisiana, Florida, and Alabama Gulf Coast, 70-degree temperatures, you notice that the dew points down there this morning are also around 70. So we've got nearly 100% relative humidity and very, very moisture-laden air down across the southern states, especially Louisiana. There's not a place in Louisiana where the dew point's anything comfortable being less than 60. Same in coastal Texas. Look at how sharp the dew point contrast can get across the state of Texas. I wish we had some observations immediately west of Houston and Dallas, because you'd see these dew points that are over here in Amarillo and Lubbock. They're probably characteristic of the central plains of Texas too. Dew points about 30, then suddenly you jump into the 50s and a little further to the east into the 60s. This is a feature known as the dry line, and it's quite characteristic of the central part of Texas and the southwestern United States, south central United States. And part of it has to do with the orography to the west of the Rocky Mountains. Part of it has to do with the very sharp escarpment orography in West Texas. But we have a substantial dew point gradient, which really does in turn focus the activity of thunderstorms. And you'll see there's a line of pretty intense activity right through central Texas into Oklahoma. And that'll show up kind of right where the boundary of this substantial dew point contrast is. Everywhere else in the country, the dew points are low because the temperatures are low. We had a 1 degree temperature and 28 dew points, so we're nearly saturated. That's why snowflakes or melted snow, freezing rain might make it to the ground here today in the morning, but that won't last too long. Now, let's take a look at the satellite imagery over the Continental 48 and adjacent waters. And really, the only game in town is this cluster of cottony-looking clouds in the infrared, and they're blowing up over Texas. They're blowing up over Louisiana. These are all convective storms. This is all thunderstorm activity. Notice the difference in the complexion of the clouds in the satellite movie in this stuff to the east over Kansas, Oklahoma, Texas, Arkansas, compared to this lower cloud that's hanging around over New Mexico, Colorado and the panhandle of Texas, and then western Kansas at the end. They don't look the same when you look at them closely. The ones to the east are much more cottony. They seem to be whiter, and then the ones to the west are grayer. They're cottony because they're convection, and they're white because they're getting so deep, so high into the atmosphere that they're radiating at very low temperatures. Temperatures that almost make them look as cold as outer space. Of course, they're not, but that's why they look so white. And look at how widespread all this convective thunderstorm activity gets in a very short amount of time. This is only a 6-hour movie, and so you can see a really rapid increase in the coverage of these thunderstorms. Okay, and so we'll get a close-up here in just a second of what's going on in that region. And this is going to be a visible satellite movie. Here it is. Visible satellite movie starting at about 7 a.m. local time, maybe closer to 8 a.m. local time. And here's the state of Arkansas sort of centered in the picture. A little bit of northeast Texas, and then parts of Tennessee and Missouri. And look at these places like right here in the western Arkansas, where it looks like the clouds are sort of bubbling over, right? That is what's called an overshooting top in a thunderstorm. So the updraft of air, and we know that rising air cools, and in the cooling produces or increases the relative humidity and then produces cloud matter, either tiny cloud droplets or sometimes ice particles, and you can start to produce precipitation-sized particles in turn. So these overshooting tops, they push through the tropopause boundary and in a very local spot where the updraft is really intense. And so then around them, there's regions of little waves, and you can see these waves particularly obviously here in Tennessee and far northeast Arkansas. See those little waves? Those are waves that are excited by air that's rising up and bouncing onto the tropopause, and then the tropopause is so stable because remember the temperature increases with height there, so the stability is very large there. It's so stable that it's like bouncing a rock on a surface of water, and you create waves at that interface, and you can see them on these really high resolution satellite movies. So this is just beginning to take shape, this line here especially, from near Little Rock and then to the southwest over to northeast Texas. That line is going to be a severe thunderstorm line. And so it's ugly underneath this, but it's kind of pretty to look at it from the top, from space. We'll see better examples when we talk about severe weather near the end of the term of these overshooting tops. These are rather benign versions of them, actually. We'll see even more dramatic versions of them later on. But this is just a nice close-up, visible satellite image, though it's in black and white, a visible satellite image of what's going on down there in this heavily convective region, places that we're kind of worried about for the rest of the day. Here's the larger continental scale radar, and boy, can you see, this is right where we were just looking, right in here. And look at how speckled in red that is. There's a whole line, continuous line of really intense thunderstorm activity that's going across the state of Texas now, making its way towards Louisiana and into Arkansas. And that continues up into Tennessee, parts of Missouri. So this is wild. And look at the stuff back here over the panhandles of Oklahoma and Texas. Not speckled with orange, red, and yellow. It's not convective. It looked different in the satellite movie. It looks different in the radar. And then here's our few showers of rain, probably in the southern part of the state, and snow in the northern part of the state coming across Wisconsin. So this is a really nice signature of a scary sort of day in a lot of places, a lot of our fellow citizens under the gun for some scary looking weather. In fact, here is the severe outlook for today from the National Weather Service Storm Prediction Center. So in red, we have a moderate risk of severe weather, and we're seeing some of that already realized further to the west. So this is for later in the day. And then in orange, you have an enhanced risk. It's just scary, and it covers a lot of famous and big cities across our country. It even extends up into Illinois in the marginal risk for thunder later on today. That does not appear to invade our state. But this is the broad region of severe threat for the day today. And it's a pretty interesting looking day coming up. And then finally, the West Coast satellite image. As I promised, look at the beautiful pair of cyclones that are sort of off the coast of northwestern United States, but heading towards the panhandle of Alaska. This one right here is a really beautiful storm with a cold front that goes all the way down to the region where the cursor is. And look at how it wraps around itself beautifully. Very obvious counterclockwise rotation, where after the exam on Friday, we're going to begin talking about the mid-latitude cyclone and elements of it. So within a few weeks, we're going to have a really solid explanation of why these cyclones consistently have this rotation as manifest in the satellite picture. And there's no way they can't, as it turns out. It's physically mandated by all of the rules that govern the way the air moves in the atmosphere in the middle latitudes. And then here's a second storm to the south. Starts out as sort of a cluster of all these pretty intense convective showers, but then it evolves into its own little counterclockwise swirling circulation. Looks like a little shrimp. They look like commas, don't they? And that's how we sometimes describe them, as comma clouds. So this is a really beautiful example of a second storm. So if you're out here in this part of the ocean, the Pacific, the Gulf of Alaska, first you get battered by storm number 1, and then you have to worry when you look to the south and you see a bank of dark clouds heading northward. You got another one coming, so you want to try and get yourself back to port before the second storm hits you. That's going to be a brutal voyage that you've just undertaken. You don't want to be involved in that.